Hello, everybody. So we're up to week 8 now, the last week of the semester. Sure, everybody's getting tired, ready for that break. I know I am. My plans next week are to sleep in and then follow that up with a nap a couple days in a row before I really do much of anything else. Been an exhausting semester. So we're getting very near the end. And along those lines, remember the semester does end on Sunday, December 18th, 11:59 p.m. So please make sure all assignments have been gotten to me before then. I never accept assignment homework past that date. That was the date that was on the calendar when you registered for the class, so that's the final cutoff. I don't accept any work after that date, and I don't give any completes. So make sure everything is to me before 11:59 p.m. on Sunday, next Sunday. Preferably well before then. The sooner is better. And on Monday morning, I will wake up and finish whatever grading is left and submit the grades. And I wake up early in the morning, so I'm usually done with that by 7 o'clock, 7 or 7:30 in the morning. Grading and submitted. I think wrapping up here, about all that's left is the final project and the second Unity tutorial, and then any past due assignments. So, yeah, please get everything to me as soon as possible to get those grades in. Let's see. Otherwise, today we're going to have a visitor from academic advising stop in after a break around a little after 2. Just come in and talk to everybody about registration and things. Some new things in the system. She's got a couple things to talk about, but she'll be here a little after 2. So I guess first thing is some more in-class examples of building games, because there is one big thing we haven't seen yet. I'll go ahead and start Unity and start this up. I always like to wait until class starts to do this. I know it takes a few minutes, but some people are here on campus, some people log in on Zoom. You might not have had a chance before class. So I'm going to open that same example we've been working through the last few days. That first 3D example, kind of a random thing. It has a few of the components for a game. It doesn't quite seem like a game on its own, but working those components in so we can see how they go together. But something we haven't done much of this semester is dealing with enemies. I guess in the snowman game, there was an enemy that moved across the screen, but that's not typical movement. Usually we have something more complex than that. So the first thing I want to look at is put a couple of enemies in here, and if time allows today, maybe an NPC, which is going to be very similar. The difference is one of them, when you go up to it, it'll do friendly things, and the other one will try to kill you. Basic, nothing fancy there. And really, there's nothing special about it compared to what we've seen before. The thing that throws people off is they expect there to be an easy way to do it, and there's not good shortcuts for how we do that. First thing I'm going to do is look at the script we have in our player. If we open up the script where we're moving that dragon around, in order to move, we check what the current position was. Then we got some input from the user. The human decided whether to move in the horizontal or vertical direction or reply. So 3 choices there. And then we just adjusted the current position by whatever the user decided. to do that for so to do that for an NPC or background character or directly the enemy in the game, we have to do the same thing. We have to make a decision and then adjust the position based off that decision. But there's a lot more involved in making the decision because the computer has to do that. And it has to be set up well ahead of time. We can't just wait for a human to hit a different key on the keyboard with whatever their reaction time is. So we actually have to set all that stuff up. So to start with, need to add some enemies in the game somewhere. So I'll come over here, a place where I can kind of see the world. Over here looks, put one down here in this little valley in the desert world. That seems like a good place to start. And what I'm going to do is create a 3D object, just because we haven't been doing that separation of logic and graphics in this example. So I'll just, instead of creating an empty and then giving it a child object, which we've already talked about is much better form, so we can just update our graphics later, I'll just make our enemies cylinder. That's a good shape. And I'll give it some sort of name. Bring it over here where you can see it. Let's see, it's an enemy of the dragon, so I guess I'll call it a knight. Maybe a red knight. And then we'll just give it a red color to keep it. Make sure it stands out unique. So for that, we'll need a material. I'll just create a new material. So right click in the assets and create a new material we can put on there. And I'll just call it red. Which, just for a quick example, we just need to pick some sort of reddish color. That'll work. And then on that thing, get the zoom thumbnails out of the way. Go back to that 9, I'll just scroll to the bottom and replace that default material with that red one. Oh, whoops. And then replace it. Drag it over there and then it should replace the default material. What else would we need? So it came with a collider already. It looks like that collider is entirely inside of it. So I'm going to scale that out a little bit. Or just do it here. 0.5. That's too small. 0.9. That'll work. 3. So it has a capsule collider, which is kind of like a sphere, but you stretch it out in the middle. So there's not directly a cylinder collider, if you did a sphere and then put a cylinder in the middle of it, so the curved parts are at the top and bottom. That's often a good shape of collider for your human characters. It generally follows those, what we would expect to see from those characters. So I can get that matching our shape roughly. So there's not a bunch of extra. That'll work. And instead of going and making a good, spend a bunch of time making a good character, we'll just go with a basic shape for this. That'll represent a character, and we have lots of time to go over later and make a really fancy looking knight with a bunch of animations, swinging his swords around and stuff. That'll be the dragon's enemy. But we don't really have time for that in the classroom. And we've seen the basic idea on how to do that. We've seen the very basics of it, and then doing more of that is just lots more of the same thing. Then I'll start this right above the ground. And we're gonna need something similar to what we had, with the dragon. Well, this is gonna represent a person. Doesn't look very much like a person, but the name says knight, so it looks kind of like a person. So we want laws of physics to apply, like gravity pulling it down. Ultimately more, but really we'll just need that component like we've seen before. In order to get the laws of physics in there, we need a rigid body component. Where's that character? There he is. It looks like when he settled down on the ground, he just fell straight over. So that's another one we saw before. It's not that right. Laws of physics are going to take things like center of mass and balance into consideration. And that really gets, that really shows when you go to a human shape, because you have done that stuff basically subconsciously since you were a baby. But it did take you a couple years to figure out how to do that stuff. And at that point in life, that's pretty much all you were doing, right? Trying to figure out how to walk and get all those subtle balances. So when you start seeing them like a computer running the laws of physics, it's a good reminder of how much we do subconsciously for every movement that we make as humans. Four-legged animals are much easier to keep upright. I think on this one, we just don't need to rotate. And we might want to spin around that vertical axis, the yaw position. We're only going to move forward and back. Get into the yaw pitch and roll. But we'd still like, in most games, we'd like to be able to turn back and forth still. Turn to the left or right. So we don't want to freeze rotation everywhere. Just freeze the rotation on the X and the Z. Because those are the two that we could, I guess, like the tripping axis. If we rotate around the X axis, that's like tripping. Or same thing with the Z, depending on which way we consider forward to be. And that's where we would spin around that. So now at least the character is standing upright. We saw a collision the other day. Let's duplicate the collision. I'll just put it on the dragon because we already have a collision for the dragon. And we probably want several enemies, so I'll do the same thing we did with the tag again before. I'll select that red knight and then give it a new tag so we can recognize all our enemies. I did that really quick. Let me do that again. On the red knight up at the top, right underneath the name, there's an option for tag. I see people looking at the monitors here, and Zoom call is right in the way of it. There you go. I don't think it'll cover anything there. So if we select untag and then add a new tag, we could say this thing is tagged as an enemy. So like a little name tag, that way we can spot everything. And remember that when we go in that way, even though we went through the red knight to create that new tag, it doesn't apply that. So we have to come back to it to actually apply that tag. Then we can go basically repeat what we did the other day. We have something, if we make a choice on what to do when we run into one of the gateways. And this is the reason why I kind of hinted at this the other day. I don't usually use an else block in game development. That's just something I've developed over the years. I stopped using else and only use else if, where I can explicitly put a condition every time. Because and just avoid any default conditions altogether. Same thing here. So like if we added another scene, we just want to explicitly state that. Or here, instead of doing an else, because right now we have two things to hit. But if time allows today, we also want to have an NPC. So there's going to be a third thing we can collide with. So we don't want to have that default condition that we just have to change later when we have more stuff. So over the years, I've found it's much better to just always explicitly put the case in for gauge. Same thing we did, we can check what we collided with. So if our collision dot game object is, that's the part we really care about. There's a collider there, but we don't think about the colliders colliding. We think about that thing the colliders are wrapped around. So when we're thinking and planning, we think about the game objects. And it has a tag, and if it has the enemy tag, I hope I spelled correctly. I might have to double check that. When I typed enemy, which I know is spelled right, in the text editor, that seemed different than what I just typed a moment ago for some reason. We need to figure out what'll happen here. We don't really have a good fatality animation for our dragon, right? Probably flip it over or something. It wouldn't take too long to animate stuff, but we play some sort of animation to show the knight defeated the dragon, then flip that over, and then restart the scene. So I'll just restart the scene, but might need some sort of indication. On Wednesday, we will probably put some words in this section right here, throw some stuff up on the display, like I don't know, throw some words or some sort of indication. But for right now, we'll just restart the scene. That seems like a good way to do that. And to restart a scene, we do the same thing as if we were going to another scene. We just have our scene manager, and we just have it load the current scene instead of one of the other scenes. And well, we could do it for each one, check and see which one we're in. But I'm going to kind of combine those two things we did earlier. So scene manager load scene, and we want to load the current scene. Scene manager get active scene tells us what scene we're on. We don't need to know the name or anything like when we did the condition last week, but we do know how to refer to whatever scene we're currently on. And we'll just reload the current scene. I wanted to make sure and explicitly state that somewhere too, because that's very common. Start the level over. We don't have time for lots of booby traps in the classroom examples, but your game is probably going to be full of things that would take away the player's health or take away one of the player's lives and make them restart from the current scene. Maybe not at the beginning of the game, right? Like player has 3 lives, and as they go through those, they can restart the current scene, but after going through all 3 of them, then they have to restart the whole game. I guess it's the standard way to do that. And our normal rule of thumb for programming, we're want to run a check every chance we get. We only type 2 lines of code, but if we run a check and there's a bug, we know we have a 50-50 choice on which one of those lines has a bug in it. So always run a check every chance you get. Even if it's only 1 line, because if it's only 1 line, then you know exactly which line has a bug in it. So it cannot convert from the scene to a string. Should we look back at our script? Scene manager.get active scene returns the entire scene, but like we did in the condition, we do just need the string. We we don't need everything there is to know about that scene object. We only care what the name is, because we load scenes by the name. That's one of the most common mistakes to make, right? Forget, even though it was on the line right above us, it probably made perfect sense without described it, because we don't need that part. But, so you want to watch things like that. Yeah, now we can check this. Just give it a quick run, and I guess I have to walk backwards to get over there. But when these things collide, it should restart our scene. Nothing too fancy there, same stuff, all stuff we've seen before. And movement's kind of the same thing, except that how we control it. Because the movement we saw is coming from human decisions. But for the enemies in the game, we don't really have a human to make that decision. So once again, we'll create a new script to control that movement. I'll just give it the same name as the thing. I'll call it a red knight. Doesn't exist, so we'll create a script with that name. And open that up and delete that. And I just remembered I was supposed to look up the button for the template again. I'll try to look that up before Wednesday. Is that you that asked, Dylan?
Yeah.
Okay. There is a template where you can change how this opens up, and it's not in an intuitive spot. Usually that's in generally in preferences on most of our IDEs. We can always change the template. It's labeled correctly, but the one time I clicked that button, I dug around for a long time. It's just like, okay, it's in a very unintuitive spot. But the template can be changed, so we can have to do things like I just did here and make adjustments before starting to type the code. And this is going to look very similar. I have a side-by-side option here. Yeah, probably. There we go. That's not going to fit very well like this. If I make the font just a little bit smaller, we also be able to see, think y'all will be able to see that. I see head nods in here. Font size 23, let's go 17. What that looks like. So it'll fit a little bit better that way. And if I hadn't done that in class, that's one of the things I really like about the Sublime text editor is it's made for programmers. So when we go to change settings, we get to go reprogram it. We don't have to go dig around looking for checkboxes and input fields and things like that. So we'll do something similar. We need the transform data. The speed is moving. That's just what's needed to make something move. Private transform data. I'll just call it transform again because it's private. We won't need it and don't have access to it outside of this script, so it'll never get confused with other transform data. Speed, we might want to gain access to. Load speed. The knight can't fly, so we don't need that. That was something different. All we have is a cylinder, so we definitely don't really have any animations yet. I guess we could change the material for an animation, but not really any animations on it. So we can go ahead and assign our transform data. It's on the same object, so we can just call it get component and grab whatever transform data is assigned to that object. Nothing new there. Well, in order to move, we need to do the same thing, so we'll need to grab the current position. So I'm going to copy and paste that from the other one. Just grab our current position. And now we hit the part that changes. How is that going to move? And there's a couple different ways. One is often built into just about every game engine you will open, and that's called paths. And over the years, I've found it is almost exclusively easier to do that in the code than it is to figure out how to use the path feature in whatever game engine you're using. Because the path is just a selection structure. And so you go that way for 20 frames, then go that way for 20 frames, then come back at some angle for 20 frames to get back to the starting point. Or that one worked out. Go that way for 30 frames, then that way for 40 frames, then come back at some angle for 50 frames, then you're walking around the triangle. A really easy thing to implement in code, but the tools that always put those in interfaces, it at least seems to me like it's more difficult. Maybe it's just because I know how to implement it in code, so I lose patience and give up on those built-in tools pretty quick. There's lots of different complex pathways. We will see another one. Oh, we might see another one Wednesday. I think we'll run out of time. And that's the navigation mesh for the AI. We set up an AI and say, okay, this area is walkable. That area is not walkable. Our character can step about 6 inches high, can walk up things up to about 50 degrees or something, and set up those criteria. And then the AI just handles the movement. Those taking the 248 class, we will definitely see that there. That's the other common one you'll see in 3D games, because then you just like click at the spot you want to go, and your character figures out how to walk there, and your hands are free to do other stuff on the keyboard. It's called a navigation mesh. I don't think we're going to have time for it this week, because it takes a lot of setup. It's not difficult to use, but there's a lot of settings, a lot of minimum number of settings to make it work. So I don't think we're going to have time for it today or Wednesday. So that gets us our position, and then we just need to figure out that control. And there's not really a shortcut for this, because it's going to be unique every single time. We have to come up with something unique every time. Maybe I'll do 2 of them, copy and paste this into a blue knight and a loop up or something that moves randomly. And first off, I'll do the path, because normally our characters can work in some sort of path. So if, and I'm actually going to leave this condition blank. We'll come back to the if, because there's something we always want to check first. And then we'll walk around our path. Else if that main thing that we wanted to worry about did not happen this time, then we'll just walk in some direction. And again, there's timers built in, but building your own frame counter is really, really easy. Every time the update method runs, we increase by 1 frame. That's every frame of the game, and then we can just base stuff off that and don't have to worry about the changes and little things. If you want to do a clock thing, a specific clock thing, like very precise timing, you would want to use delta time, which is just spelled out like that. There's a variable called delta time, which is a floating point number of how long that frame took. So you would just multiply that by your speed and all of that. That's a common one. You'll see that used a lot in tutorials. But if you're not using the full out laws of physics, calculus-based laws of physics, if you're not using calculus in your code, then there's less need for something that has delta in it. For anybody that's got that calculus class, that's how we define everything, the change. So that'll show up again more in these 248 class. But you will probably see it in tutorials if you look. So that variable delta time is just holding what the last frame took. So obviously, we don't know how long the current frame is going to take until we finish it and check the measurement. But it should be close to the amount of time that the previous frame took. So delta time is also always off by 1. It's giving you the previous frame and assuming that's the length of time the current frame is going to run at. But we know that's not always the case, but they will be close. They should be really close to each other. So it's reasonably accurate. A frame counter is really, really easy. So then we just need an integer, private int, I'll call it frame. And then at the very end of our update method, we're going to put these curly braces in and come down so I don't lose track of that. In update, I was starting to notice a lot of curly braces with nothing, no code around them. It seemed like an easy place to get lost in the text file without some labels there. And the very last thing before we go to the next frame is we can just increment that frame counter. And then that gives us a nice little way to check our path. We could do a similar thing on distance. We could measure the starting point, just take that starting position. And if we've moved 50 meters from that starting position, then change. So, and then when we check that in the if else if block, we would check exactly the same. The only thing that's different is we're measuring frames of the game, milliseconds that have passed, the position, however you want to measure it, whatever makes the most sense in your mind. They're all about the same because then we can check things. So let's say if else if frame, I don't know, let's try to walk in 15 frame sections. Oh, that wouldn't be very long. Or that'd be 1/10 of a second. We need more than that. I believe by default it should be set at 140 frames per second. So we'll walk some direction for 3/4 of a second, which handy to have a calculator around, right? Let's say we'll walk in a direction for 3/4 of a second, then change, walk another direction. That might be even a little bit too slow. Or I'll just put I'll just do a whole second. Instead of punching that in the calculator, 1 second might be a good first check. So if frame divided by 140, or frame mod 140 should give us some sort of remainder. And we'll walk around our path every second. Or we'll give it a 3-second path. So 140 is 1 second. 140 times 3 is 420. So if we divide by 420, that's how much we have. That's how many frames we have for a 3-second. And then I'll just divide that down into quarters and we'll walk in a big square or something. Or maybe not even a square. So maybe for the first 150 frames. So if whatever we get when we divide by 420, whatever the remainder is, if it's less than 150, then we're in our first section. So we'll move in the Z direction, which in our movement is just like we did here. So I'll copy it from the other file. Once we have the decision on how to move, where we set up a new vector, where X, Y, and Z are the same at first. Speed. Yeah, I guess we can just do plus speed in that direction. So we'll start by walking in one direction for a little over the quarter of the time we have in our 3-second loop. That part's exactly the same as we saw the other day. What's different is that logic. and see how position could be the same thing. If you know the size of like the village you're walking around, or the guard is patrolling, and the castle of night is patrolling, you can take the start position and just move that distance to get to the next one. If it's not less than 150, so frame 420, we could check to see if it's less than 150 to another 75 would give us 150 might be too much. Let's start at 130. 130, and then we'll walk over for 45. Also, green mod 420 is, oh, sorry, that one's wrong. Did that look strange to any of y'all? That should be 130 plus another 40. So we go one direction for 130 frames, and then we'll turn and go a different direction for 45 frames. And of those 45, 130 are already accounted for, so 130 plus 45 frames. Or we could just type in 175. If not that, well, we have our first 130 frames plus the 45 frames. And I usually do write it this way instead of going ahead and calculating that number, because then if I come back and edit it, I have to think about what that number is. And just throwing magic numbers in there, so at least seeing the equation can help give some reminders about that. Then I guess another 130. Where are we at there? So 130 and 130 is 260. 420 minus 260. Okay. 130 plus 45 plus 130 is 305. So that leaves us a long way from our beginning point. The 150 would work here. Let's switch this to 150. Oh, actually, I'll keep it at 130 and I'll just change the other number. 130 plus 130. And then we need one more block in our square. Another 45 would get us right back to the starting point. Because we're doing this at the same speed every time, right? That first number is going to need change on this. Frame mod 420 is less than 130 plus 45 plus 130. Actually, I'm just going to do an else here. And the last 45 frames will get back around. So then how many do we need? So 130 times 2 plus 45 gives us 305. And then another 45 frames would be 350 frames. So we want to loop on a 350 frame cycle. And whichever way we measure it, notice how there's a little bit of math that goes into this. Whether it's positions, the frame counter, which frame counter is kind of the easiest one to do. But we'll set up something so that it keeps going around. We're going to come back and do this. So for right now, I'm just going to put false in the if block so that it never runs the if block until we test the other stuff. But then we'll do kind of the same thing. Copy that actual movement instruction into each other little segment of our path and then change it accordingly. So the first time we'll go in the Z direction. And the second time we'll go in the X direction. Then to get back to the start, we need to go in the negative Z direction, and then the negative X direction. So that part hopefully looks familiar, makes sense. And what's different is how we are adjusting, how we are deciding which one to use. And we'll come back and do the if part. There's something we want to check before we just walk around the map. Hopefully some of y'all realize what that thing we always want to check first is, because there's an important part that we don't want our enemies just completely randomized in the game. Just come back over, do the normal check for errors. I only see yellow things, so I'm just going to ignore them. No red in the console. That's usually a good sign. And when we run it, hopefully we'll see that character moving around. I can turn the camera. It doesn't seem to be moving, does it? Oh. Oh, something got off. Why is he not moving? Anybody have a thought why he's not moving? Speed. Yes. If y'all on the Zoom call can hear him, they said we hadn't set the speed value, it's still assigned to 0. So he might have been moving, but we can't really tell. Let's see what 0.2 looks like. Probably way too fast, but oh, well, he's moving now. Actually, that might be pretty good on movement. Looks like he's covering that area, that one little area, pretty nicely. Maybe a little fast though. So if we slow him down, he would need to move for longer to cover the same amount of area. Which that's sort of the things we have to check out. So that speed was probably a little fast. If our animation is a knight sitting on a horseback, then maybe it would go that fast. But compared to the speed our dragon's moving, a human would not move that fast, right? So I'll slow that down. How fast was the dragon moving? I'll just use that speed. Speed 0.1. 0.09. Because our dragon's the main character, right? That's us. We want to be able to outrun the enemies if we have to. But we also want it to be challenging to outrun the enemies. We want to make it just difficult enough for the player to outrun the enemies that it's fun to do so. Right? We wouldn't want the enemy moving at 0.01 and us moving at 0.1. Because if we're 10 times faster, then there's no fun to outrun the enemies. So we're just barely faster than them. So we won't always be able to outrun them. Kind of have a head start, or at the very least start at the exact right moment. Because now's that other thing that we haven't addressed yet. Oh, I guess we need to check. Down here, move backwards. So now the area where he's covering is a little bit too small. So maybe increase our frame counter would work, since we took away from the speed. We need to increase our frame rate, which as your games get complicated, that is definitely something you won't want to punch in the calculator. Right. 0.09 divided by 2, divided by 0.2 is 45%. So if we're 45% slower, we need to move for 45% longer. Because in the real situation, you're going to want that accuracy when you make little adjustments like that. We could just kind of approximate it. So then 45% of 130 would be about another 50 frames. 58 is what they have. 58.5, but I'll try 50 more frames. And then 45% of the 45 frames for our other sidebar square would be 20.25. Well, I guess 58 would round up to 60. So to keep with that thought, we need our circle to be about 45% bigger. So 130 is going to increase to 190. And I'm going to go through and make all those changes and then come back and do the other one. So 45% of 130 is 20 frames or 60 frames. Then about 45% of 45 would be another 20 frames. So now come through and add on those 65, 65. And yeah, this is kind of bothering me. So if frame mod 350 is less than 190 plus 65 plus 190 plus 65, because that number is the one we actually want. So it's a case where it has to be less than that number. But that thing I just said, over the years, I found that it's almost always a better idea to take direct control over that and avoid that default loop. So what's that give us now? 190 times 2 plus 45 times 2. I got 470 frames. So 470. The main point there is notice how we do have to do some math and a lot of thinking and a lot of planning, even for something as simple as just walking around the square. You also want to do checks and make sure you don't eventually walk off the edge of the world or something, or get stuck in a little, the way our landscape's set up, we have those cliffs and like little things overhanging random spots. You don't want to get stuck in one of those by a hill and you can't walk up, because then that throws everything off and it's hard to predict where you'd be in the future because the computer is just going to keep following that pattern. Back over to Unity and give this a quick look to. So like here in our world, it looks like there's a nice little area here where I could patrol and other scenery there, like a little castle we're trying to get in and destroy. We have to avoid that patrol of the knights to destroy the castle. Would be a step that we don't have time for that would make it actually gameplay. So, move the camera this way and then start backing up. There we go. Oh. Can't get my camera in a good spot to see it. There we go. So you guys kind of walking around. Something looks like it's not quite even there at the end. And we keep getting further and further to the left. There is something in the math. I was just looking to see if I saw confused faces. These numbers all add up to exactly this, right? So there is a frame where we are not less than this number. But then other things can have impact as well. In this case, we're moving a certain number of pixels each time, and frame rate changes. Remember, 140 frames per second is our goal. It's not a guaranteed thing. So depending on what else the CPU needs to do, that's going to get a little bit off. In short, that's what we have to do though. We have to build this big selection structure and check keep it moving in a pad. Be careful that you don't skip frames. If we would have kept that as else, we wouldn't have skipped a frame. So y'all can quickly figure out that that was one of the errors I wanted to explicitly point out, because I talked about how that's better. Always have control, but be careful of when you're doing your math, because there will come a point when our remainder is not less than that number. That last final exact one. And now for this one. But before we do all of that, following a path, there's something important we need to check. What's the first thing we need to check? On those names from our characters, our player is a dragon and the enemy is a red knight. So a knight should probably be trying to actively hunt the dragon, right? So we also need to come up with a point figure out if that knight should chase our dragon. And do that, we can just check a distance. Distance to player. And to find distance, we'll use the Pythagorean theorem. We don't need all of our values. I'll just draw the overhead thing. So here, if we're looking down from above, we have our Z and our X axis. So maybe the players here and the knights here. So if we want to know what the distance between them is, well, that distance between them is this straight line right here. Okay? But from what we've seen in vectors, that straight line between them, since we're on a plane, can be viewed as a right triangle. So we can use our Pythagorean theorem to find that. A squared plus B squared equals C squared, or C is the square root of A squared plus B squared. Since that initial form isn't something we can plug into the computer. We need the form we can actually put in the computer. C is the square root of a sum of other squares. And if we need elevation, the Pythagorean theorem keeps applying. If you have 3 dimensions, there's just 3 things summed together equals that straight line between them. Or if you're in 12-dimensional space, 12 things squared and then summed together equals the straight line that would get to that final endpoint. So the Pythagorean theorem directly scales up to any number of dimensions. I guess we would need to call it D instead of C. But A squared plus B squared plus C squared is D squared. So we just need 3 values if we're in 3 dimensions. It applies no matter how many numbers we have to plug in, basically. So that's the next thing to do, but we have a guest coming in from academic advising shortly after 2. So we should probably take a break before she gets here, and then we'll pick up from here afterwards. But does that movement make sense? And during our break, so that's what we'll do after the break. But during our break, see if you can come up with any questions on how we might modify different things we could do. Then after the break and our visitor, we will look at this distance here. And then we'll do another one where we just move in random directions. basically the same thing, only instead of a specific direction, we're choosing which direction to move in each time and then move in that direction. But we should probably take 10 minutes before Samantha comes in. Does that sound good to everybody? I see head nods in the classroom. So my laptop says 1:56. We'll get back to it at 2:06. Or yeah, be back in here at 2:06. And that should be about 3 minutes before she comes in. 4 minutes. That was the strange math I did.